We're on pages 60 and 61 of our textbook, Unit 2, Lesson 4, Inverses of Linear Functions. Recall that one-to-one functions have inverses that are also functions. Except for horizontal lines, all linear functions are one-to-one and thus have inverses that are also functions. So any line except for horizontal line is a function and will have an inverse that's also a function. So let's look at some. Exercise number 1. On the grid below, the linear function y equals 2x minus 4 is graphed along with the line y equals x. Okay, so here's the graph of y equals 2x minus 4. And I'm just going to go over y equals x. That's this diagonal line that bisects the first and third quadrants. That's y equals x. How can we quickly tell that y equals 2x minus 4 is a one-to-one function? Well, first, for a function, it passes the vertical line test, the VLT, and one-to-one, it passes the horizontal line test, HLT. Graph the inverse of y equals 2x minus 4 on the same grid. Recall, how do we do that? It's easily done by switching the x and y coordinates of points on the original line. So I'm going to take maybe just 2 points, this one here, which is a y-intercept, 0, negative 4. And I'll take this point here, which has coordinates 3, 2. That's all you need, 2 points to determine a line. So I switch these x and y, our coordinates. So 0, negative 4 switches to negative 4, 0. Plot that point, negative 4, 0. 1, 2, 3, 4. And 3, 2 switches to 2, 3. Plotting that, 2, 3. And then I could take a straight edge and connect those. And here we have the graph of the inverse of y equals 2x minus 4. See what can be said about the graphs of y equals 2x minus 4 and its inverse with respect to the line y equals x. Well, in relation to this line here, y equals x, they are reflections of each other in that line. Find the equation of the inverse in y equals mx plus b form. So this is slope-intercept form. The y-intercept is right here, which is 2, so b is 2. The slope, we can simply count. If I go from this point, the y-intercept, to this point here, I go up 1, and to the right 2. So our slope is 1 over 2, or 1/2. Our equation is, let me change the color. Our equation is y equals 1/2 x plus 2. Now, given a linear equation, we want to find its inverse. So steps to finding the equation of the inverse are, we switch the x and y variables in the original equation, and then we solve for y. And yes, you must memorize these steps. So we switch the x and y in the original equation, and then solve for y. Which of the following represents the equation of the inverse of y equals 5x minus 20? Doing the first step, we switch x and y, so x equals 5y minus 20. And now we solve for y. Now we want to get y by itself. Solving for y, we would first get rid of the subtraction of 20. We would add 20 to both sides. X plus 20 equals 5y. And then divide by 5. X plus 20 divided by 5 equals y. So we have y by itself. Now, in this case, this doesn't quite match what we have here, so let's take each term of the numerator and divide it by 5. So this is one single fraction we can split up into two pieces. This is x divided by 5 plus 20 divided by 5. X divided by 5 is the same as 1/5 x, and 20 divided by 5 is 4. So y equals 1/5 x plus 4. And that matches choice 4. Although this is straightforward, common errors are often made when solving for y, so just be careful with each algebraic step. Which of the following represents the inverse of the linear function? Okay, so remember our steps. We switch x and y to find an inverse. We switch x and y, and then solve for y. Write it down, that's going to help you to remember. Switch x and y, solve for y. Okay, so x equals 2/3 y plus 8. Now solve for y. Subtract 8 from both sides. X minus 8 equals 2/3 y. Now, dividing, this is 2/3 times y. We can divide by 2/3. But you should know this. Dividing by the fraction 2/3 is the same as multiplying by the reciprocal. So the reciprocal of 2/3 is 3/2. So we're multiplying by 3/2 both sides. And we multiply the left-hand side by 3/2 each term there. The x and the -8 has to be multiplied by 3/2. All right, in doing so, this is 3/2 x. And then 3/2 times -8. If you need to, grab the calculator. 3 times, if I put that over 1, 3 times -8 is -24, and 2 times 1 is 2. -24 divided by 2 is -12 equals y. So 3/2 x minus 12, which matches choice 2. Number 4, what is the y-intercept of the inverse of? Okay, so they're asking us for the y-intercept of the inverse of. So we first need to find the inverse. First, let's find the inverse. Switch x and y. X equals 3/5 y minus 9. Solve for y. Plus 9 equals 3/5 y, and multiply by the reciprocal, timesing by 5/3. Put that in parentheses on the left-hand side because each term there has to be multiplied by 5/3. Okay, and let's see over here. So we have 5/3 times x, 5/3 x. 5/3 times positive 9. 5 times 9 is 45. 3 times 1 is 3. 45 divided by 3. Come on. 3 5/3 equals y. And 45 divided by 3 is 15. So we have 5/3 x plus 15 equals y. And this is our slope, right? This is y equals, this is mx plus b. So our y-intercept is the 15, which is choice 1. Again, with any of these, you're always welcome to pause the video and work through getting y by itself on your own. Sometimes we're asked to work with linear functions in point-slope form. Okay, so remember what point-slope form looks like, right? Point-slope form is y minus y sub 1 equals m times x minus x sub 1. The method of finding the inverse and plotting it, though, do not change just because the linear equation is written in a different form. Exercise 5, which of the following would be an equation for the inverse of, and here we have y plus 6 equals 4 times x minus 2. So yes, this is slope, point-slope form. The slope would be 4, the point would be 2 comma negative 6. Not that we need to know that, but okay, so if we're finding the inverse, we switch x and y, so we have x plus 6 equals 4 times y minus 2. Oh, wait a minute. Does this match anything? We just switched x and y. Almost, not quite. It almost matches one of these. Alright, so it looks like, let's just get our y minus 2 by itself to start off with. Alright, so let's get rid of this 4. Dividing by 4 is the same as multiplying by the reciprocal. So I'm going to multiply by, let's squeeze it in here, multiplying by 1/4. Oops. So I'm timesing by 1/4, but timesing by 1/4, timesing by 1/4. Alright, in doing so, we have, I'm not actually going to distribute that, I'll just leave that, just kind of looking at the choices there. So it looks like we have 1/4 times x plus 6 equals y minus 2, which is one of our choices. It's choice 1 here. So we can stop there. Exercise number 6, which of the following points lies on the graph of the inverse? Okay, we want a point that lies on the graph of the inverse. Well, remember, this here is written in point-slope form, so this is y minus y sub 1 equals m times x minus x sub 1. A point that lies on this line, a point that lies on this line is negative x sub 1 is negative 2. So negative 2 would be our x sub 1, and 8 is our y sub 1. So a point on this line would be negative 2 comma 8. Therefore, a point on the inverse, we would just switch the x and y. It would be 8, negative 2. 8, negative 2. That's choice 1 again. We're getting a lot of choice 1 answers here. And number 7, which of the following linear functions would not have an inverse that is also a function? Well, if these are all linear functions, with the exception of horizontal lines, have inverses that are also functions. So the only one here that is a horizontal line is y equals 2. That is a horizontal line. That is choice 2. Okay, that concludes our lesson for today. Thank you very much for your attention. My apologies, I circled option 3 and wrote the number 2. Let me erase that and correct it with option 3.